Our next small topic is something called the elasticity of demand. The idea for the elasticity of demand is how much do small changes in the price of an item affect the demand of it? You know, it's a pretty simple idea, right? If your item's priced too high, the demand's going to be low. If the item's priced too low, the demand's generally going to be too high, but unfortunately that's going to minimize your profits. So there should be some perfect price that we could find that keeps the demand as high as possible and our revenue as the biggest as possible. To do this, we need a demand function. Not sure why, but the book calls this Q. We're going to call this our demand function. So this tells us what the demand for a product is at the price X. So let's take a look at this. This is called the elasticity. Now this is not the way the book gives it at first, but it says d prime of x over d at x all over x. Now the book's going to throw a negative in here, and I'll do that in a second. What would this value tell us? Well, this down here, this would be the average demand, because remember, every time we take a function divided by x, that's the average demand at x, and this is the instantaneous demand at x, so at that exact price, so the average over this. Well, I'm going to simplify this just a little bit, right? If we divide by a fraction, we multiply by the reciprocal, so this is going to be x times d prime of x all over x. Now, because this value ends up being negative a lot, we kind of put the negative in front just to make it a positive answer, to be honest. So that's where the negative comes from, because this is how we define the elasticity. But here's the idea. We have this ratio here. Now, this value comes in three different ways that we can answer it. Either E is going to be greater than 1, E is less than 1, or E is exactly 1. Well, if E is greater than 1, we say that this is elastic. If it's less than 1, it's inelastic. And if E is equal to 1, that probably has a name. Off the top of my hand, I can't remember what it is. Actually do this. Pause. I'm back. I went and looked it up. I was right. It really doesn't have a name here. They just say that it is maximized. So yeah, I was right. It didn't really have a name. So why would these kind of make sense, or at least what do these mean? Well, if this value, and I'm looking up here because this is more of our ratio here. If this is greater than 1, that means the top is bigger than the bottom. That means that in this case, the instantaneous rate of change is bigger than the average, which means that with that change, we're most likely going to want to decrease our price. So if the elasticity is greater than 1, we want to decrease our price, right? Because the instantaneous rate of change is bigger than the average. So you kind of want those two things as close to possible. Now, of course, the other way around, if E is less than 1, that means the instantaneous range is smaller than the average. That means you can up it a little bit. That means that you can increase the price. And if E is equal to 1, that means that the instantaneous rate of change of the demand over the average demand is perfect. So this is the perfect price. So when you're selling something, of course, you're always looking for the perfect price of the object. So these questions are generally very, very straightforward. Come back over here, grab an eraser. Let's get these out of here. So let's say the demand function is given by d of x, let's do 40 minus 2x. Okay, so let's do this. Let's find the elasticity of demand. That's the first thing we're going to look for. Evaluate E of, I don't know, 2. Let's see what that is. Hopefully that's not exactly right. And then step 3, find the maximized price. So here we go. We have this demand function for whatever we're selling. Who knows what we're selling? What we have X. So let's plug it in here. So our elasticity function, E of X, will be negative X times, right? I'm just reading off here. Negative X times D prime of X is negative 2 all over D of X is 40 minus 2X. So cleaning this up just a little bit, so E of X is positive 2X all over 40 minus 2X. Okay, so that's our first part. There's our elasticity function. We wanted to evaluate this at 2, so E of 2 would be 2 times 2, 40 minus 2 times 2, so that's 4 over 40 minus 4 would be 36, or 1/9. Okay, so what does that mean? Well, this is less than 1. So what do we say? This means that this is inelastic. Spell that right? Inelastic, which means we should raise the price. Right? So if we were going to charge $2 for this, we would actually be able to charge a little bit more if we wanted to try to maximize our revenue. So what price, what value of X should we actually sell this for to get the maximum amount of profit? Well, I'm going to go this way. Well, we said that the maximum amount of profit happened when the elasticity was 1. So our elasticity function is, I want to know when 2x over 40 minus 2x is equal to 1. Well, that's easy enough to solve. Clear your fractions. Minus 2x times 1. So when 2x is equal to 40 minus 2x, let's get our 2x's to one side. 4x is equal to 40, dividing by 4, we get x is equal to 10. So yeah, at $2, we were selling it way too low, right? That's way too cheap to sell this. The market, apparently from our research, if this is really the demand at that price, says we should be able to charge as much as $10 for this object, and that would give us the max amount of profit. If we charge any more than that, the demand will go down. People's like, I'm not paying that much for it. And demand would go down, and we'd actually make less profit. So the elasticity of demand is a very simple function that lets you know what's the best way to set the price for your product, whatever your product happens to be.